Hello, hello, students. Happy Friday. Go ahead, if you would, and get out your journal and open it to page 307. Open up that journal, turn it to page 307. We're going to skip number 3 today and just look at 1, 2, and 4. So skip number 3 and just look at 1, 2, and 4. Okay, so yesterday we covered section 10.6, and 10.6 really talked about 3 different theorems, all of them involving how lines and line segments intersect with a circle. So sections 4 and 5 were more looking at angle measures. Section 6 is looking at segments and then their relationship. So we looked at 3 different scenarios yesterday. One where 2 chords intersected. One where a tangent intersects with a secant segment, and then one where 2 secant segments intersect as well outside of the circle. So we're only going to see 2 of those today, and I will warn you that on number 1 there will be some factoring involved, but it's not too terrible a factoring, so I think we'll be okay. Okay. We're going to start off here with number 1. So numbers 1 and 2, we're looking at where 2 chords intersect inside of the circle. Or I guess you could also think about them as secant segments if you wanted to, just the pieces of the segment that are actually going through the circle. But those look like chords in this case. And we learned yesterday that when you have 2 chords intersecting inside of a circle, that they create these sort of pieces that when the pieces of the chord are multiplied together, their different products equal each other. So here's what I'm saying. We have 2 different chords here. Here's one, the one in red, and here's the other, the one in blue. So if we split the red and the blue chords up into different pieces, the product, multiplication, of those pieces will equal each other. So let's look at the blue chord first. If we think about this chord being 2 different pieces, what 2 pieces am I looking at here? Well, that would be the x, that's one piece of it, and the x plus 1. Now, x does not equal x plus 1. It's not like they're bisecting each other. They're not cutting each other in half. As you can see on the red, one section is 5, one section is 6. But we're going to multiply them together here. And does it matter which way you multiply? No, because multiplication, we know order doesn't matter. 5 times 6 and 6 times 5 are the same thing. And then we're going to take the 2 pieces of the red chord, the 5 and the 6, and multiply those together. And then we're going to set those products equal. So anytime you have 2 chords intersecting inside of a circle, the pieces multiplied together will always equal each other. Okay, and then from here we're going to use algebra to solve for x. So on the left side with the blue, I'm going to take the outside x and I'm going to distribute it through. X times x is not 2x. That would be x plus x. That's different. X times x is x squared. X times 1 is just 1x, so I'm just going to put x there, but if you want to write 1x, that's fine. And then 5 times 6 is 30. Now at this point, algebraically, I have nothing else that I can combine. I don't have any like terms. I don't have any other x squareds. I don't have any other x's, and I don't have any other constants. And we can't use this as like a linear equation where we would just subtract something over and divide, or subtract something over and square root. So from here, we're going to have to move the 30 over. So in other words, set your equation equal to 0. Because then once you do that, I can factor it. And that's where my 2 different solutions will come from. Now when we factor, and the leading coefficient is 1, and leading coefficient is the number in front of x squared, when it's 1, all you have to do is think about what 2 numbers multiply to negative 30 and are going to add to 1. So you guys did this little x thing last year, which you guys know I'm not as familiar with. But you want to multiply to negative 30 and add to positive 1. So I'm just going to ignore the little x thing just because the leading coefficient's only 1, so we really don't need it. So let's think about our factors of 30. Factors meaning what multiplies to 30. 1 and 30, 2 and 15, 3 and 10, no 4, and then 5 and 6 would be the last one, okay? You want a combination of numbers that is somehow going to add to 1. Now, yes, it's negative 30, so one of those numbers is going to have to be negative, and we'll get there in a second. But you just want to think right now, what combination, which number combination could possibly give me 1? 1 and 30? No, you can add 1 and 30, and you can subtract 1 and 30, and you do not get 1. 2 and 15? No, too big. 3 and 10? 10 minus 3 is 7, 10 plus 3 is 13. That doesn't give me 1. 6 and 5, right? You can take 6 minus 5 and we're going to get 1 here. Now, when you decide, we're going to have an x and an x here, because that's how we multiply to x squared, and then a 6 and a 5. Now, one of those has to be negative, since you want to multiply to negative 30, but you still want to add to positive 1. So you have to think in your head, which one of those needs to be positive and which one needs to be negative if I want to add to positive 1. And hopefully you're thinking needs to be plus 6 and minus 5. And if you were to go through and box method that, you would get x squared plus 6x minus 5x, which is where the 1x comes from, and then 6 times negative 5 would give you negative 30. Now, when you think about your answers here, we're going to take those factors, and in order for this whole thing, this whole product to equal 0, either x plus 6 needs to be 0 or x minus 5 needs to be 0. One of those would need to be 0. The only way to get 0 is if you're multiplying by 0. So then when we solve for x, our options are negative 6 or positive 5. Okay, those are your two different options for what x could possibly be. Now you have to go back to the problem and think what makes sense. One of those answers can't possibly work when you plug it in. And that's going to be your negative answer. We can't have negative amounts. And if I plug negative 6 in for x, that doesn't make any sense. We don't have negative lengths. So your only option here and your only answer is going to be that x is 5. Okay? Now, the second one conceptually is the same thing, but you're not going to have to factor in this one. Yay! Okay, so once again, we have two different segments here. Here's one segment. And the two pieces of that segment are 15 and 5x minus 2. So we'll multiply those together. And then our second segment is this blue one. And the two pieces are 10 and 7x. Okay, and you always have to multiply the pieces that are on the same line segment, the ones that are collinear. Like you can't take 15 times 10 and then 7x times 5x minus 2. That won't work the same way. All right, on the left side, we'll go ahead and distribute this. 15 times 5 is 75, so 75x minus 15 times 2 is 30. 10 times 7x is 70x. Now this one is a two-step equation. Be careful here. I'm going to leave the negative 30 where it's at just because it's already alone, like the constant's already alone. So I'm going to move the 75x over. Now it's okay if you move the 70x over, but then you need to add your 30 back over to the other side. Otherwise you're going to get a negative number, which we don't want. So then I bring the negative 30 down. 70 minus 75 is negative 5. Divide by negative 5. And my final answer is positive 6. Positive 6. Okay. All right, that was one of your theorems. Now, the second theorem, when you have the two secants that are going through the circle, I don't have an example of that in the warm-up today, but you'll have an example on the scavenger hunt, just so you know. This example, though, with the tangent, you have a little tangent piece, the one that's only on the outside, and then you have one of the secants going through. So I'm going to start over here with the tangent piece. Okay, here's the tangent piece, meaning it's strictly on the outside. Remember, tangents never go through circles. Tangents intersect in one spot on the outside. They never go through. Our little theorem says the tangent piece squared. So we're going to take this x plus 1 and we're going to square it in a second. Equals, now on the secant piece, be careful here. We're not going to take x minus 1 times 5. The theorem is the tangent piece squared equals the secant segment, the piece on the outside of the circle, times the entire secant, not just times the piece on the inside. So if we look at this entire secant here, or secant segment rather, the outside piece is this x minus 1. So we're going to take the outside piece, not times 5, but times the entire thing. Now, when we write the entire thing here, when you add two segments together, it's going to look like x minus 1 plus 5. So let me go ahead and write that down here. X minus 1 plus 5. That's essentially what we're doing. We're taking our x minus 1 little top piece and we're adding 5 to it. And when you add that together, negative 1 plus 5 is going to give you positive 4. So my entire length here of the secant segment is really x plus 4. Okay? And that's what I'm going to multiply the x minus 1 times. So I don't just multiply times 5, it's always the outside piece times the entire thing. Outside piece times the entire thing. Outside piece times the entire thing. One time my brother told me if you say something 3 times that you remember it better. So there you go, said 3 times. You'll want to know that today on your scavenger hunt. And if this had been a problem where you had 2 secant segments, you would just use that same logic on the other side. Outside piece times the entire side would equal outside piece times the entire side. Okay, well, let's go back here. X plus 1 squared is going to be like x plus 1 times x plus 1. And from here, we're going to go ahead and box method both sides. So I'm going to do 2 different boxes here. I'll just go ahead and draw them right underneath the problem. So x plus 1 times x plus 1 on the left side. X times x in the first box is x squared. X times 1 is just 1x. 1 times x is 1x. 1 times 1 is 1. 1 times 1 is not 2. Be very careful. And so on the left side, all we do is just combine our like terms here by adding. I still get that question a lot. Do we add them or do we multiply them? You're going to go ahead and add those together. So we end up with x squared plus 2x plus 1 on the left side. That's what the blue was. X plus 1 times x plus 1. X squared plus 2x plus 1. Quick little box method there. Okay, on the right side you have x minus 1 and x plus 4. Remember, it does not matter which one you put on top of the box and which one you put on the side. So I'm going to put the x minus 1 on top just because it was listed first, but I could have put the x plus 4 on top. It really doesn't matter. Okay, first box here, x times x is x squared. X times negative 1 is negative 1x. 4 times x is 4x. 4 times negative 1 is negative 4. It's multiplication in that bottom corner. It is not addition. So if you have 3, go back. And then add the like terms together. So we're going to add the 4x and negative 1x, and we end up with x squared. 4 plus negative 1 is 3x minus 4. Okay, looks a little funky right now. Now, there's something on both sides of the equation that's 100% identical that we get to go ahead and cancel out. Hopefully you're thinking in your head, the x squareds? Yep, we're going to go ahead and get rid of the x squareds. And then we're left with 2x plus 1 equals 3x minus 4. A little bit easier to look at here. Two-step equation. I'm going to go ahead and minus the 2x over, and I get 1 equals 1x minus 4, add 4, and I get 5 equals 1x. Divide by 1 if you want. That was kind of the unnecessary step, but if you wanted to divide by 1, there you go. Okay. So again, you did not see an example in the warm-up today of where 2 secants go through, but when you have 2 secants going through the circle, just remember outside piece times the entire thing equals outside piece times the entire thing. Okay? Awesome. So here are your instructions for the rest of today. you are going to see 10 little stations around the room. It's going to be a scavenger hunt. Yes, you need to complete all 10. And your homework today will be the sheet that the sub gives you that goes along with that scavenger hunt. So this scavenger hunt is going to be for credit today. So unfortunately, you cannot just stand around doing nothing. I don't care if you do it by yourself or with a group. If you want to do it with a group or with a partner, everyone needs to fill out their own sheet. So you cannot turn in one sheet for a group of 3 people. Everyone needs to turn in their own sheet if you want points today. Okay? Now there's 10 stations around the room. If you look at the top of each station, there's an answer. So like a scavenger hunt, you will work through the problem, and then the answer has to be somewhere around the room. There's 10 of them. If you are not getting any of those answers, that should tell you that your answer is incorrect. Or if you don't get to all 10 stations, that means you did something incorrect before. The key to it is in my subfolder. So if you need to see like, hey, where did I go wrong? Where did I mess up? You could look at the key there. And that will be turned in before the end of the period to get your credit for today. It doesn't matter where you start. You can start wherever you want, and then it should eventually link you back to where you started in the end. All right, if you have any missing work, you can always set that on my desk and I can grade it over the weekend as well. But that's all I got for you today. So once you're done with the scavenger hunt, you'll be done for your day. I'm in the South Gym if you want to come visit me, working on the blood drive stuff. So that's all I got for you. If I don't see you, have an absolutely fantastic weekend. Bye, guys.